Well, well, well. So it's come to this. We are finally going to talk about containers. I kept mentioning them and you kept asking about them. So finally we're going to talk about them. Now I know you've heard of VMs, at least I hope so, virtual machines. We're going to talk about that too. But what is a container? I mean, is it the same thing? Is it something different? Is it like some kind of really crazy weird thing? Well, they seem to be more popular than like AI at an ML convention. But I mean, we really want to talk a little bit about what is it and what's the difference in a virtual machine and a container. So stick around for Secure Digital Life.
This is a Security Weekly production.
Welcome to Secure Digital Life. If your users are going to keep putting risky stuff on your machine, you're screwed. So Top can help us understand the complexity of blockchain.
I was reading through the show notes, man. And oof.
In binary, it would be 001. Who cares? But it's probably not significant anyway. Be like you're looking out through the HAL dot, you know, like,
oh,
hey Dave, Dave.
It's like Sims, but with, you know,
it would be like Sims
instead of AI. It's only.
Accredited by Microsoft, Cisco, NetApp, IDLE, Oracle, and EC Council, QuickStart delivers high-impact, low-cost IT training through its cognitive learning platform in multiple domains. With QuickStart, you get an ever-growing catalog of courses, self-paced courses offered through a monthly subscription, virtual classrooms offered through an annual subscription, peer-to-peer learning, mentoring, official courses, certified instructors, hands-on labs, and more. For more information, visit www.quickstart.com. Use coupon code PAUL20 to get 20% off on all cybersecurity courses. Quick Start, creating world-class technologists. RSA! The RSA Conference 2019 is coming up March 4th through the 8th in sunny, actually usually not so sunny, San Francisco, although San Francisco is still a really nice place to go. Go to rsaconference.com/securityweekly-US19er to register now using the discount code 5 Uniform Niner Sierra Whiskey Foxtrot Delta to receive $100 off a full conference pass. And if you're interested in booking an interview or a briefing with Security Weekly at that conference, please go to securityweekly.com/conference request to submit your request. Also, Wick, join us April 1st through 3rd at Disney's Contemporary Resort, for InfoSec World 2019, where you can connect and network with like-minded individuals in search of actionable information. Visit https://infosecworld.misty.com. That's MISTI. And use the registration code OS19-SecWeek for 15% off the main conference or World Pass. And again, if you're interested in booking an interview or a briefing with Security Weekly team who will be there, you can check that out. You should go to those. I went to both of them last year. They were really fun. RSA is crazy. It was like mini DEF CON. There were so many people. There was actually maybe more people there than at DEF CON, and although more of them had on ties and things, but it was very cool. The whole downtown of San Francisco was just like swarming with people, and there was
ties.
It was, yeah. Well, not all of them were in ties. There was people like me there too, but it was pretty nuts. Mm-hmm. I didn't realize it was this big. I had never been to RSA before, and it was just like huge. And then InfoSec World was lots of fun. It's inside Disney, so you can hang out there, and we did that last year, and it was fun too. So yeah, so
cool.
Russ is joining us today. He's actually here live again, which is
I'm live.
Live and in person, live in leather and riding motorcycles. And well, we don't want to see the lace part, Russ. Let's just leave that to you. Let's keep some things to ourselves. But we're going to talk today about containers a little bit, because people keep writing me and saying, what's a container and why is it different from a VM and all these kind of things. So I want to talk about that a little bit. And I started seeing containers, I don't know, like 2 years ago, I guess. I started hearing people talk about containers and Docker and all this kind of stuff. And just so you know, Docker is a big product that actually makes containers. So it's a way to build containers or buy containers. And the other word that everybody hears all the time is Kubernetes, like Kubernetes. And Kubernetes is a management system for containers. So these are two, and there's other stuff out there, but these are two biggies that you hear people say all the time. And if you watch Security Weekly, you hear people talk about Docker and Kubernetes and stuff like that. So it's definitely something that's come along. Some of it's a mainframe thing. I always sort of put stuff in the cache of old mainframe stuff because mainframes had shells, so I could create shells for individuals or groups or all kinds of things. And these shells in the mainframe actually contained everything you needed to function. And so there's that piece of that shell in the mainframe. It's to me, very similar to what a container actually looks like in the world. I don't know, what do you think about that?
No, I mean, the mainframes that a lot of people, my colleagues, were trained on were like the AS400s and stuff like that. So IBM going back a little bit of time, and some banks and some organizations still use them. And then we moved to sort of one desktop for everyone, one computer per person.
Mistake.
Yeah, and now we're back sort of in the virtualization.
We're back in the mainframe world.
Yeah. So it's kind of interesting.
Mainframe was good. I mean, it really was. And I mean, it's not just because I'm old. It's like the idea was good because it's good today. Because it's the same thing. We don't say that today. We talk about, we call it other things, but it's really the same concept as what the old mainframes were like, which was about sharing stuff. And yeah, that whole movement where they did the decentralized, and I remember I was there. I heard the sales pitch about, we're going to put the user, empowering the users. You, as a user, will now be empowered.
Biggest mistake we made.
Take charge of your life. You will have your own computer on your own desk, and you will manage it. And that means we won't need those lousy bastards down in IT anymore. And that was, of course, the whole essence of it, because they all hated us. I mean, they hated us so bad. And they wanted to take charge of it until they got control, and then they realized, oh, this isn't a good idea at all. A lot of election outcomes, but
misconfigurations ran rampant, viruses ran rampant.
It was nuts.
And then Windows released, 2000, Windows 2000, and I mean Linux has been doing.
I still remember this day the very first call I got from the accounting group in the mainframe operator center. The person called and they said, so we have these new computers, and I'm having some problems with it. It won't come on. And I was like, yes, you've been empowered.
Install your own OS.
And I was like, you'll need to fix that. And she was like, what? And I was like, well, they took away all our budget for support, so you're calling the wrong place, because guess what? You are now in charge. You will fix your own computer. Yep. Have a nice day. And then, a month later, they were like, can we get rid of these things? And they took them all to the storeroom, and they quit using them because people wanted their terminals back. Yeah. So then they kept crawling. And I told them they were going to come crawling. I was like, you'll be on your hands and knees begging me for access to the mainframe. And, and guess what you're going to get? Nothing. Nothing. You're going to get I get a little worked up about that.
Derez.
Well, actually, we deprioritized was what I was trying. I was trying to get that out. Deprioritize, because I said, well, see, since you don't have any budget now, you don't get any support, and you're the lowest priority job. So that means like the thermostats are going to get priority over you. And they're like, okay, I guess we'll have to put up with that for a while till we can get new budget allocated. And literally all those IBM PCs went into this storeroom, and nobody used them. There was hundreds of them sitting there. It was ridiculous because they were just, there was no mechanism for that.
Right.
But VMs are very much a mainframe idea. So I brought this motherboard, which is defunct. So I've got this big monster motherboard here. So this is a huge one.
Pure titanium, by the way. It weighs about 7 pounds.
Yeah, if we melted this baby down, I'm telling you, we could make a whole bunch of coins out of it. But I brought this motherboard in because I wanted to just sort of use it to illustrate the idea of virtual machines and mainframe. Now, this is a big honking motherboard. Yeah. I mean, this thing, this one had 64 gigs of RAM. It's an i7 chip, I think, and it's a big motherboard. And multiple people could use this motherboard. I mean, it could easily handle a lot of jobs at the same time. So what if I take this and give it to one person? Well, maybe it's not the most efficient use of the resources, but that's not the biggest problem. The biggest problem is all this. So you got bridges. You've got chipsets, which are they're like here, but I know you can't see them. But you've got chipsets. You've got ports. You've got all these things that are going on this motherboard. Every single motherboard is a little bit different. I mean, you get all the same motherboard, you're good. But when you mix another one in, I should have brought an extra one so I could hold it. But you bring another one, all of a sudden you need drivers. And you need all these components for this motherboard to get it to work. And so if you've ever tried to install a different operating system, so if you said, I'm going to install Gentoo Linux, for instance, one of the first problems you ran into with that was there's no drivers.
Right.
So they make, this is ASUS Republic of Gamers is where this comes from. It's called ROG. And ASUS makes drivers for common stuff. So if you go to ASUS's website, you can download motherboard drivers for Windows 10. No problem. 64-bit, 32-bit. They got all that. But if you go there and you try to download drivers for, I don't know, something weird,
like Linux or whatever.
Well,
some
Linux, they probably have Linux drivers today. I was thinking more like you try to download something really weird, you know. What would be the weird
BOS? Remember that system?
Yeah, OS2, you know, something like that. But I mean, they won't have drivers for those things, and the problem with that becomes, and their drivers for Linux may not be very good. So it may work on Cent or Red Hat, and it may not work on Ubuntu or Gentoo or Debian branch stuff. And the problem with that is what happens when you want to run those things. And you can call ASUS and be on hold for 19 hours, and I shouldn't run them down. I use their products all the time. But I've never called their tech support, so I have no idea what they would do. But, I mean, and they may immediately spring into action and write new drivers for you, but somehow I doubt it.
That was a big problem for those of us that were interested in getting into Linux in the late 90s, early 2000s. The hardware didn't support it. You had to either write your own drivers, join some sort of secret society that created their drivers and distributed to these people, members only.
Exactly.
Or whatever. So, that was a problem for us.
Right. So one of the earliest ideas, which again came from mainframe, was separating the users from the hardware. So I want to get you and what you're doing away from this hardware as much as I can. And this is usually called an abstraction layer type of problem. Just like in programming, we write abstraction layers to keep you away from the machine language.
Right. You're not using assembly.
Right. So we let you write in Ruby on Rails, and that all that space between Ruby on Rails and the processor is called the abstraction layers. And I use that same term here because I want to get you away from this. Because you maybe, I mean, if you're interested in it, and I'm not talking to you, but I mean, if you want to write your own drivers, cool, but most people don't. So when you want to slap a video card in this, it needs a driver. The driver has to interface with the motherboard. It has to work with your operating system and your monitors and everything else. Well, what if I could get you away from that? I just want to tear you away from this physical thing. If I was really bold, I would throw it into the corner, but I actually think it could cause severe damage to both the studio and my well-being.
It's a baby.
Yeah, because it weighs about 10 pounds. But if I want to get you away from that, I need some kind of an abstraction layer. And that abstraction layer that came into existence is called virtual machines. And so the idea of a virtual machine, and we kind of have to explain what a virtual machine is, because if you don't understand that, I think you're really going to struggle to understand what a container is, because they're not the same thing. They're similar things, but they're not exactly the same thing. So a virtual machine, essentially, by my sort of loose definition of it, is an abstraction layer between the hardware and whatever you're running on top of it. And that abstraction layer in virtual machines today acts as a standardization kit. So what they do is somebody like VMware, they write drivers that interact with all this hardware. So if VMware has a driver for all this stuff, then they use their drivers, and you're good to go. And everybody wants VMware to work, so they make sure there's drivers available for that kind of stuff. Now that type of, and they call it bare metal a lot of times, because a bare metal hypervisor, this is the term, a bare metal hypervisor is a piece of software that sits on top of the hardware and acts as an abstraction layer between you and this, using standardized drivers. So when you go into a VMware, they have a collection of standard drivers, and it's always the same. So they have the same driver for the NICs. So all these NICs, this one's got 2 NICs in it. So there's a chipset for these NICs, and these in particular are Intels. So these Intel NICs, they need drivers. Well, VMware has them. Now the operating system you're running may not have drivers for gigabit Intel NICs, but that doesn't matter anymore, because VMware has a standard driver that is sitting in there that will work with almost anything. So what happens when you do a VMware is you install your operating system in the virtual machine, and the virtual machine then gives you a nice collection of really nice standard drivers. They have chipset drivers, they have NIC drivers, they have drivers for video and all this kind of stuff. You don't see any of this stuff. And that abstraction layer then converts all that down into the motherboard, and you don't see it. And that's a mainframe idea. I mean, that's exactly what a mainframe was doing. So it was creating a shell. I put your stuff in there. But the mainframe is a lot more like a container than this. But that's essentially what a virtual machine does. Now, in a virtual machine modern, you can install most any operating system. So I have installed just about everything in those, from Microsoft stuff, and old Microsoft stuff, new Microsoft stuff, server stuff like Active Directory server and all those kind of things. We have those running in virtual machines. We have all sorts of Unix. So I have everything. I don't think I have a Unix, like a pure Unix, like a BSD Unix or anything right now. But I have Mint Linux, I have Ubuntu Linux, I have CentOS, I have all those things running. And I don't have to do anything with the drivers. Whereas in the old days, I had to go in and I actually wrote a driver for Gentoo once because I didn't have any choice. It was the only way to get it to work, and somebody really challenged me to get it working, so I did.
And then with the VMs too, it's not just about abstraction layers for the hardware. Now, what you can do once you create that is you can partition a certain amount of hardware from the machine and give it to certain users. Right. So if you have 5 users in the accounting department and you only have enough budget for one honking machine, like say this, then you could allocate, say, 8 gigs of RAM per user, right?
Oh, it's 3D. Sorry.
8 gigs of RAM per user, and then would be allocated. And then the same thing with GPU, which you don't really need much of unless you're running. AutoCAD
and again, that's what the mainframe did. So the mainframe's got all these processors on a big board, and I come in there and I say I got 185 engineering students who need to use a mainframe, and what I do is I slice it up. So like sitting right here is, I think, 32 gigs of RAM. So, because this I think had 64 gigs. So I think this is 32 gigs of RAM sticks sitting right here. I could divide that up into giving each person 2 gigs of RAM. So now instead of everybody getting, trying to buy a machine that's got 32 gigs of RAM for everybody, I can just split this up into 16 users who are going to share this 32 gigs amongst themselves. Same thing with the processor. Now these processors, this is an i7. I think it's got 8 cores on it. So I can actually share the cores. So I can give you your own core. So I give 8 people each their own core on the processor. So that's like your own very own processor. Or I could further slice that up, and I could share the cycles of the processor among a whole pile of users, so that the 16 users are all sharing this 8-core processor with just what they need to use. Same thing with the video, same thing with the NICs and all these other things. Now, to you, if you're using that virtual machine, you would have an operating system that looks like a clean machine. And as far as the operating system is concerned, it's all very real. So the operating system won't typically know.
And neither will the user.
You wouldn't know either unless you didn't realize there's not a computer sitting there.
And the other thing that's good about the virtualization side of things is it's dynamic. Unless all 10 users are turned on and using their resources at once, you're not going to have a full tax on the RAM or the hard drive or the processor.
And again, that's what the mainframe did, because you heard me say earlier that I was talking about deprioritizing people. Well, you could set priority for people on the mainframe, and you could say, well, this is Doug's machine. He gets top priority. And over here is bad old Dr. I won't say what his name was. We'll make up one. Dr. Smith. Danger, Will Robinson. Good old. That wasn't Dr. Smith. That was the robot. But, Dr. Smith was like, oh, the pain. But Dr. Smith, we don't like, and so we give him really low priority. So that means when I request resources, I get them ahead of him, and so forth. And you can do that with virtual machines as well. Today, most of the virtual machines that you're going to encounter are of a couple of flavors. My top 3, and there's other ones, so I'm sorry if I don't mention yours. The biggies, so the big commercial ones are Hyper-V, which is provided by Microsoft. I've never used it. I have access to it, but I've just never set it up. And no offense, Microsoft. I've heard it's a perfectly reasonable product. And VMware. And I have a site license for VMware, so I can set up VMware on hypervisor. And so that's bare metal hypervisors. So I take a big monster server, a lot bigger than this, and I build a bare metal hypervisor onto it, and then that bare metal hypervisor takes this and it makes it shared by a bunch of users, and I can create a lot of virtual machines. Now, the virtual machines don't necessarily even interact with each other. They can be isolated. They can be put into their own little world and whatever. So VMware, Hyper-V, and the other one I was going to mention was VirtualBox.
And that's Oracle, and
that is owned by Oracle.
And I use that as well with my students.
And I use it all the time.
It's free. I mean, well, for the most part.
No, it's free.
I don't know if there was an enterprise version or something.
I don't know, but I mean, I have that on.
VirtualBox is free.
So I have that on my machine at home.
Same.
In fact, this machine right here, I was using VirtualBox on. So because I have 6 monitors, and I could literally open a virtual machine on every single monitor, and they're all running different operating systems. So I could be running Linux at the same time as I'm running Windows.
Exactly.
And that hypervisor is then just managing all this stuff. So it acts as an abstraction layer between the hardware, which is really weird when you start thinking about it, is that, it's just converting all that stuff. But I could literally have, I have had as many as 6 machines running all at the same time off this motherboard. And that's a pretty cool thing to be able to do. So that's essentially, in a very brief discussion, what a VM is. So moving on, we can talk a little bit about containers then. So containers is a different mainframe idea, but it's very similar to the VM. A container is take this a step further. So take the abstraction layer now and go further than where we were. So we were sitting there with a virtual machine. So that means you've got a brand new computer sitting on your desk and you want to do something with it. So you install an operating system, you install software, all these kind of things. A container says, let's take that further. Most people don't want to install operating systems, even on virtual machines, because it can be tricky. A lot of companies don't want their users to set up unique things, because that makes support very, very difficult. I mean, whenever you're criticizing IT, just turn it around and think about what if you were in that same boat? Or what if Doug was running it? It would be like the iron fist and the iron glove.
and the iron curtain.
Yeah, exactly. I like iron. But I mean, IT, we all complain about IT all the time and talk about, well, they won't let me do what I want to do. But the truth is that somebody has to support that. And when you go in and you say, can you support Linux? Can you support Windows? Can you support BSD? Can you support everything under the sun? And they're going, well, yeah, give us enough budget, we'll hire staff. But you can't train people up to do all those things and do them well. So the container idea was, then what if we could take the virtual machine idea and extend it? And so what you do with a container is you literally build this kind of black box, although I always, for some reason, think of them as ovals. Like big, I don't know why, it's weird. They're always very egg-shaped in my head. So like a virtual machine is just but a container is always this egg-shaped sphere hovering in cyberspace. And you don't necessarily know what's inside the container. The idea of the container is that take this and put everything you need into the container. So just an example I was using before was a video game. So let's just say you want to sell people a video game. And this is now a little bit out in the future, but we're not doing this right now. But what if I could just take the video game? I could take all the libraries that the video game needs. I could take all the drivers. I could take all the features. I could take any other tools. I mean, if you ever played modern video games, they have tons of back-end stuff, and you can download worksheets and books. And what if I just took all that and I put it inside of a container? And the idea of the container is then the container just kind of hovers down into your world, and it's sitting above maybe this, which you put an operating system on here, and there's a container inside that operating system, or maybe it's a virtual machine, and the container's inside the virtual machine. So now there's that abstraction layer. Now there's another abstraction layer, because that abstraction layer of the container is acting as an interface between all these products that are inside of it and the operating system. And in fact, it can even reach all the way down to the kernel of the operating system, so that it's getting a direct interaction from what's inside the container and the OS. And the idea of this, of course, is that it works. Because if any of you have ever run a video game, installed a piece of software beyond something like Notepad, you know that you do get problems. And you're going to spend time out of your day. You wanted to play, Legends of Next Year, The Coming Storm. And and we've all had that experience. You went down to the, today we just download them, but, we used to go to the video game store and GameStop or wherever, and you buy, Legends of the Coming Year, The Coming Storm. And you bought it, and you spent that $89, and you went home with it, and you're like, oh, I've got my game, I'm going to play this game. And you sit down and you start to install it, and, it gets running, and then you get blue screens of death, and then it won't work, and it says, oh, you need
your video card is too old.
Yeah, you get that. You don't have enough video memory. You don't have enough.
A general protection fault has been caused in 0x115639.
Those old B-side experiences with video games. In fact, the first desktop machine I ever upgraded was a Tandy 1000.
Wow, Radio Shack.
And I wanted to play this game called Starflight, which was just like really like now. I looked at that thing. It's so lame. It's like an 8-bit game in 2D grade. It's so lame. But at the time, it was like the coolest game anybody had ever seen. And it would not run in my, I think I had 64K of RAM.
Oh, wow.
And it wouldn't run. And I was like, oh, no. And I went to the Radio Shack, and I was like, how do I upgrade the memory in this? And the guy was like, you won't do what? And I was like, uh-oh. And I ended up buying all these chips from Tandy.
Yep.
And they sent me the chips, like bare chips in a little plastic tube, and I had to actually put the chips into a board and solder the board onto my motherboard. And the whole time I was doing it, I was going, "This is going to go badly.
This is going to end badly."
But I got that baby up to 256K of RAM.
Wow.
Yeah.
But when I had my Commodore, my first machine, it was a physical cassette drive. You know, and I was running Zaxxon was the game that I loved Zaxxon. I thought it was great.
That's a cool game. Yeah,
Rat Race was another, and Jupiter Lander.
Right.
And so I wasn't as ambitious as you were to upgrade my RAM. I was 7.
Well, and Russ really helped me out there, because my real example of this, of what a container is a video game console. Because a video game console is one of the greatest examples of this exact thing. It is hardware. So you take that Nintendo, don't do this, take the Nintendo apart. I did, and then I had to buy another one. Yeah. No, I messed mine up. Oh. I don't remember what I did, but I think
put a screwdriver in the cartridge.
I actually scratched the motherboard on it, I think. I was going to take the motherboord out. Oh. I was trying to see if I could, I could soup it up, and I souped it down.
Yeah, you downgraded it.
I turned it into soup.
Downgrading Doug.
Yeah, into that. So I had to buy another one. Well, I bought an old one, so I bought a used one. I was just going to see what it was like, and I was going to see if I could turn like a Nintendo 2 or something into a Nintendo 3. Just like I was like, yeah, there's got to be a way around this. But if you think about that video game console, it is hardware. So there's just another motherboard inside of it and everything else. It's just very standardized. Then they run essentially a virtual machine on top of that. So they've got this environment. And inside of that environment are all these games, and they have everything they need to run. So when you go in there and you download Pro Sports 5007 or whatever you downloaded, I don't know the names of those, but NFL Football Killer.
It's Madden something.
Yeah, exactly.
That's one I've seen.
Madden is a famous one. Madden Football. Was a football game, right?
Yeah. NFL Blitz has the voice in our head.
That's right. Is that the one where you get to use guns on the field?
I don't know.
Chainsaws? Cool. I want NFL football with chainsaws or something.
Oh, so it's Splatterhouse.
Upgrade your team. Mutants.
Jump so high that turn the gravity off in the arena.
Exactly. Oh, that'd be cool.
Yeah, that'd be super cool.
Yeah, 3D football.
Heck yeah.
Or 4D
football.
Don't
jump too high.
Yeah. You can play it in the past into the future. It's 4D football.
It'll be Portal and football.
It's quantum football. But all those games then are packaged, and they have everything they need to run, and you've probably very rarely put a game on a gaming platform and it didn't work. So when you go to the Nintendo store or whatever, and you're buying, Steam is another example of this. It is almost a container, because what Steam is doing is Steam actually vets the games. They download them with everything they need. So when you buy a game from Steam and it downloads onto a PC, it actually will typically work, because they are acting as it's not exactly a container, but it's just all along down those lines.
Unless you're running software from Bethesda like Fallout 76, which was a whole Fallout failure in and of itself a few weeks ago, and they were getting so many complaints from their customers. They're like, oh, we want a refund, we want a refund. And yeah, when they installed the software, the program actually wouldn't run at all.
Wow.
Yeah. How often do you hear that on PlayStation or whatever? Yeah. How often do you hear that?
Not very. And I mean, but this makes the point. I mean, this is why containers, I think, are going to start taking over, because we want more of that. I mean, we want convenience. We want to be able to just do what we want to do. And so I really think the idea of a container, which now has an abstraction layer between the container and the virtual machine that it's running in, and then that has an abstraction layer between that and the hardware, basically starts cutting you out of the game. A TV set is an example of this as well. You buy a television set, and you set it up, and you plug all these cables into it. Well, the cables are the connections into the container. You don't know what those cables even do. It's just a thing that goes into the wall. And there's all this other stuff behind it. There's hardware, there's switches, there's routing, there's all kinds of stuff going on to get that signal or that movie or whatever it is you want to see into the TV box. And the TV box doesn't even know what it's doing. It just does what it's supposed to do, which is project something onto a screen. So basically, that is a container. I mean, it doesn't know what's happening. So that film you watch is a container. And I think you're going to see more of that where you can buy prepackaged containers that have all sorts of things in them. So as we see the world move more toward the cloud, and so the cloud is, of course, where all this is getting driven from.
Yep.
If you put your containers in the cloud, that means you don't need any hardware at home at all.
Like on Amazon, for instance, on AWS.
Right. So now, so you can reach into that container from wherever you are and get back whatever it's supposed to do. So if it's a game, you're sending it signals from a little piece of hardware you've got, and it's replying with other signals that tell you what happened. But the container has the game in it. It has all of its drivers. It has everything in it, and it has an abstraction layer between the hardware. So you don't have these problems because the container should be self-contained. So it's an object-oriented idea. It's a container. It does everything it's supposed to do. It can touch the operating system kernel, so that means it can be a threat. So the last thing I want to talk about a little bit is that what would be the negatives about containers. So one of the things that's negative about containers is resources. Containers use more resources than not containers. I mean,
because the host versus and
it's a container.
The virtualization and the
So you've added stuff in there. That abstraction layer is still there, whether you see it or not. It is there, and it uses some small amount of resources. So that means you may need a bigger machine to run containerized stuff than you would have needed if you did it all yourself. Now, you may no longer need to call tech support 19 times to try to find out what that error code that it keeps throwing means, because the container just contains and it runs.
Right. But I think the containers are, for the little amount of resources that it may take up, the containers actually contain things. So if something happens to one specific container on a system, it doesn't necessarily affect another container on the system.
You will see far fewer blue screens of death and system crashes, because the container, if it did crash, would tend to crash in and of itself. And so that container may get corrupted or fail. And I'm a fan, so don't get me wrong. But that's one. It is one of the negatives I wanted to point out, is there are some resource issues that associated with it as we see more containers and you start putting more and more containers in your system. Another negative I see with anything like that is it's a black box. Now you don't know how anything works. You just want it to work, and that means you can't fix it, you can't upgrade it, you can't do anything to it unless you have permission. And that's great on the developer side, because it means you can't mess with their product and screw it all up, and you can't steal it because you can't actually get to it. It's inside of some kind of containerized world. So my example for that was a car. So you go, if you want to build a car in your basement, you can.
Yeah.
I mean, I can't, but somebody could. Yeah. My brother's done it. I mean, you go buy parts and you literally build a car. It's like totally unique. And it's like, wow. When something goes wrong with it and it like bursts into flames, he has to fix it or die.
But he knows how, because he built it. So.
Yeah, theoretically. Yeah, sure. He says he does anyway. But I mean, I want to go get a car that just works. I have no idea how it works. I just want it to work. I want to go to the Tesla dealer, and I want to sit down in my Tesla X. And if any of you would like to buy me one, I'll be happy to accept that. Thank you. I know some of you have been itching to buy me a car. I keep getting those emails. So just Tesla X black, please, and I want the black rims. I know those rims are $7,000, but I mean, I'm sorry, it just doesn't look right with the silver rims. I want the black, the matte black rims on the Tesla X. But I mean, I want to buy a Tesla X at the dealership and get in it and put the on button and say, see you around, and it works. I don't have to stop and tweak it for 4 days trying to see, I need to tune the engine a little bit. Right. I need to do this. And I think I'm going to need another cable to get this thing working. I just want to get in and drive away. And that's what a container is supposed to do for you. So one of the negatives, though, with that same system is you don't understand how it works. So the Tesla breaks, you've got a problem. You got to go to the Tesla dealer, and then good luck with that, because guess what happens when you buy a $100,000 car? Getting it repaired costs a lot of money. When you scratch that rim, guess what? And I assure you, I would scratch it really quick. I was like, oops, I hit the curb. Like, well, that cost $3,000. And I can call my wife and go, hey, guess what I just did? I just spent $3,000 more on the rims. But she's used to it. She puts up with a lot,
especially in Rhode Island.
Yeah, but anyway, the container, that's exactly what it is. It's just a fully contained thing. So another negative with it, I think, is just loss of control. Another positive with it is I think you can start to buy bundles. So if you want to buy a sports bundle of games, it's got a whole bunch of games in it, you could just buy it. They're going to sell it to you as a container, and it's going to run on the cloud. So now you just need to access it. So that
software as a service or whatever.
And I was just, and in fact, I'm going to experiment with this. I want to get a machine, and I'm going to see if I can run 6 monitors off of an AWS virtual machine.
Nice.
because I want to see if that'll work. If I can find a Zero client, and so the devices that we use to access the cloud like this are called Zero or thin clients.
Dummy terms.
And they're just little tiny things, right? And they're just little, they're dumb terminals, essentially, like we had on the mainframe, and you can plug them into things, and then they access, like AWS. So the virtual machine is running on AWS, and you just get the screen back. And I'm really interested in trying that. I want to see if I can run all my screens, and I could replace my desktop with a thin client.
Would you say cost is a negative, a drawback, or a positive?
I don't know. I haven't looked at it enough to see does it cost more to bundle everything together or to provide tech support. So is the product price going to change? Because if I need more support people because it's so hard to install, I mean, that cost gets passed along to the purchaser as well. And so if the containers give me more control, less piracy, and the ability to not have to support it so often, it might actually be cheaper. I mean, I don't think containers themselves cost the cost of the container is very low. And so if you get Docker, and you can get demos of Docker so you can play around with it if you want to, and there's all kinds of open source stuff to do containers as well. Build a container and see what you think, and put some stuff in it, because you can take a program, you can write the program if you want, put it inside the container, and then you make the container, and it will run on Linux, it'll run on Windows, you can put it where it'll run just about anywhere, and it's a really, really powerful thing to be able to do.
Yeah, I hope it doesn't turn into one of those, and it could, or I hope it doesn't turn into one of those silly, like cable companies or massively multimedia conglomerates where they bundle, all your sports packages, and I don't want all bundled sports package. I just want ESPN. I don't want ESPN 6, 7, 8, 9, 10,
I've been
12.
predicting this for years, and I actually think I know who's going to do it now.
Really?
I think it's Amazon. Because Amazon's already set up, so they've got AWS, they have every piece of the cloud, right? So they do, I mean, other people do as well, but Amazon has every single piece in place. And for a long, long time, I've been predicting that home computer use would turn into a utility type thing, so just like cable. And if Amazon comes to, think about it like this. If Amazon comes to your house and they say, look, here's what we do. We're going to put this little box over here in the corner. That sounds like cable. We're going to put a little box in the corner.
That's true.
And we're going to plug the box. Our technician will plug the box in. You have no idea how the box works. They just plug it in. And you say, how many workstations in your home would you like? And you say, well, I'd like one in every room. And I want a 32-inch TV on my refrigerator. And oh yeah, can I look into the toilet bowl and see information? It's like it's projected on the water in the toilet bowl. Like, hello, Doug. Good morning.
Perfect timing for the State of the Union, because that's where I would want that.
Let's not talk. That's where I would want that projected. But I know.
Oh, Inception. Can we?
Yes, you can put a container inside of a container. So a container, and if you want to read more about this, thanks for the question. If you want to read more about this, look into object-oriented programming, because the very basis of object-oriented programming is objects can contain other objects. So a container could take other containers that maybe were smaller or had other pieces and put them in. So again, if you own all of that, you may start assembling things. So your video game may require 50 other containers that all were built by somebody else, and you can take. And then those could also be called APIs or appies. Sorry, Paul. Paul, let me call them appies.
It's happy hour.
And doctors all think you're talking about surgery, but an API is a library, so you can put that in. And so yeah, a container could have multiple containers inside of it. You wouldn't even know. It's like a big self-contained system. Just like here, get this one, virtual machine. You can run a virtual. You can run VirtualBox inside of a virtual machine and run operating systems inside of operating systems inside of operating systems.
Provided you have the resources.
As long as you have the resources. Same thing with containers. So one drawback, if you're designing games or products for people, if you're going to sell these people this home package, so now this big, it's an egg. I'm sorry, you'll never get out of your head now. It's this big, matte black egg that's floating out there in cyberspace. When Amazon brings that to your house and it contains everything you need, I think what Russ said is exactly right. They're going to sell you a package deal, and they're going to say, are you a video gamer? Oh, you are? Well, we have this video gaming package that is included, and that's only another $8 a month, and you add that on. And then inside that container, the big Amazon egg, inside the Amazon virtual egg, there may be other containers from Nintendo. And so think about it this way. What if you containerize then PlayStation?
Yep.
And what's the Microsoft one called?
Xbox.
Xbox. So you containerize.
Or Atari has a new one coming out.
Atari's got one. The Wii.
Yeah, the Wii, Nintendo Wii. Yeah.
So all those different boxes, you could virtualize those things and their operating systems. Put them in a container. Put it inside of the Amazon egg container. And now, if you want to play Xbox or you want to play Nintendo, it's already there. And then you just bring in other things, and they can sell you all that as a package deal. It becomes a utility, and boom, that's the end of that.
Yep. And then the face hugger comes out and kills us.
Cool. All, so. I want my very own face hugger. I mean, those. Yeah. They are. I mean, all these games are in the cloud, but now I'm talking about actually bundling them up into package deals.
Container, yeah.
So I think it's a really, really cool thing. Yeah. So anyway, we've run out of time to talk about that. We kind of went long. Thank you for listening to Secure Digital Life. We will continue talking about this in the future, I'm sure, and we'll see you next time.
Don't contain me, bro.
Good one.